Rory, how are you feeling today?
I'm doing all right, not too bad. We're ready to rock.
What'd you say?
Ready to rock.
Okay, great. I am like, my body's has been invaded by aliens, and I am fighting off 2 different alien attacks, it appears. Excuse me. So, although I'm physically strong, my brain may shut down during the session, at which point, Rory, I'll rely upon you to bail us out as usual. Let's pick up where we left off. For anybody who's brand new to plugin building, I think there may be at least one of you out there who's watching this. This is a continuation of last week's webinar. The suggestion was, in fact, Rory, I don't know if you find the suggestion. I don't even remember what the link was, but the suggestion was I want to be able to implement IDisposable, and hold on a second. I can maybe able to find it real quickly here. IDispose. Here we go. That's what I want. Hold on, I think I can bring it up. Bring it over here. From James Counts.
Yes.
He wants to a plugin to add IDisposable to existing classes. So last week we started with this. We created a code provider, and we wrote some code for that, and then we refined the code. And let me just run it so I can show you where we left off. So, Rory, could you put a link in the chat window for anybody who's brand new to plugins, just to show them how to get started on this? So I'm opening up this test project right here that over the last few weeks has become kind of our general purpose test project. As we write new features, we put more code in here. So look at those 2 features. So, so here was the example code that we had starting over here. And so we have here's a properly disposed class with properly disposed resources. Well, at least it was. I've actually changed it in anticipation of some requests that came in the middle of last week's session. So last week's session near the end. Well, let me show you first what we built. So here the idea is this: I have a class that does not implement IDisposable. It has resources inside of it that do implement IDisposable, and so we should be able to come in here, hit the CodeRush refactor key, and choose Implement IDisposable, and then now we can choose it to target location and put it in there. So it gives us, there's the dispose, so we're implementing IDisposable. It adds this at the end here, and then here's our disposing, right, which was pretty sophisticated, right? It's going through, checking all of our fields. Any fields that implement IDisposable, it's putting them in here with this code. Mm-hmm. That's what we've got. So one of the requests was, excuse me, one of the requests was, it'd be great if we could show a code issue here to identify classes that have members that implement IDisposable, but we're not actually disposing of those members. Okay?
Yeah.
That's step 1. Step number 2 is, it would be really nice if we have something that does implement IDisposable, and we have new elements in it, like I've added blue brush and orange brush, and they are not disposed inside of this method.
Okay, so it'd be like playing catch-up. You maybe generated this the first time, but you've since added other things which should also be disposed. So you need a warning that maybe they need to be added to the system as well.
So what we're talking about is 2 code issues. One code issue here for this problem, for a class that doesn't implement IDisposable. A second code issue for this problem, right? And then a fix for this problem. We already have a fix for this problem, right? It's the one I just showed you, right?
Sure.
This one we have a fix for. But we don't have a fix for this yet. So it's a little tricky. I tweeted a little while ago that, warning, this could be mind-blowing. And if I'm able to keep my mental faculties intact during the session, which, as you know, Rory, is, it's a reach to even suggest that might happen. But if I were to able to do that, this will be awesome, and we will have this feature running by the end of the session. I think, though, there's going to be some intense code. One of the bits of code we have to do is essentially come down and see if we have code in here that looks like this already for this piece, for each of these pieces.
Yeah.
So there's some code analysis that's going to have to take place. I actually went through and practiced this and built it when I was in a much better state of mind. So,
okay.
so we'll see what happens. Okay, so I close that down. Back over here into the running instance. So we need some code issues is what we need to do. So let's bring up the toolbox. There it is right there. And we need an issue provider. And we need 2 of those. We also need another code provider because we need a fix. So this is going to be the fix that adds that disposes of the fields. So let's set the properties for these. So for the issue provider, this one can be fields should be disposed. Oops. Instead of setting display name, I'm going to set member name, a provider name to that. So this is a unique string that's going to identify this issue provider. This display name can change if you want to, for example, translate or localize or later change the text that shows up. This issue appears when fields implementing IDisposable are inside a class that also implements IDisposable, but those fields are not disposed. Okay, so that's the code issue there. And I'm going to give it just a meaningful name so I can see it. So it's not just issue provider 1 and 2. So we'll call this IP for issue provider. Fields should be disposed. Excuse me. That's number 1. Issue provider number 2 is going to be, the provider name on this is going to be class should implement IDisposable. And the description is this issue appears when a class contains fields that implement disposable, but those fields, but the class itself does not implement IDisposable. I'm like suddenly very nervous, by the way, Rory. Okay, so here we go. IP class should implement IDisposable. Let's go to the code provider. Code provider is going to be declare, no, dispose fields.
Yeah.
That. I'm just noticing a case convention that we use. For these, because they show up on menus, we title case these code providers. The issue providers, we actually don't title case those. We also don't put periods at the end of these, and that's just a convention, so I just was aware of that and thought I'd point that out. So this is going to be disposes of any fields that implement IDisposable inside this class. The code issue message, we've seen this before. This is a unique string that connects this content provider, this code provider, to an issue provider. We'll hook these up in the code because I like to do that in the code instead of setting the same string in both places. So what I'll do is you'll see that in a little bit. The action hint text, this is what happens if this is the only refactoring or code provider available and the developer hits the key to refactor or bring up the CodeRush menu, and there's an option that says if there's only one available, just implement it. What happens is this shows up in a red arrow or a blue arrow, depending on what it is, code provider or refactoring provider. And so what we'll say here is we'll just say dispose fields here. And this is an opportunity to provide a shorter name to something here that might be longer. Okay.
Okay.
So we'll call this CP dispose fields. And now let's go in and start handling some events. So so look at our issue providers first. We're going to go double click here on check code issues. Do the same over here. And here I'm going to do the big three: check availability, apply, and prepare preview. And often I just run, but I think before I do that, well, what the heck? Let's run. Let's run. We're going to have to refactor is the answer to this question. Oh, actually, you know what? Speaking of refactoring, holy cow. Look at this mess. Let's refactor first. You know what? I think this font is too big. Would you agree with that?
In what sense? Do you think you want more code on screen at once, you mean?
Yeah, that's what I'm saying. I think I want to go back a little bit. Is that still readable to you over there?
That's good for me, yeah.
Good for you? Okay, so this is the method I'm talking about. This is what we left with last time. Okay? And I want to break this up into something smaller because there may be some reusable pieces in here. Specifically, there's some code in here. Is this it right here? The field is disposable. If not null, this is the code that generates, there we go, that's code to dispose fields individually, each one of these.
Yeah.
This is that code, and we're going to need that again later on. So I really want this baby out. But let's look at all of this right here. Oh, and there's something else too. There's a bit of follow-up from last time as well. Let's break these apart, though, into their individual pieces. If you recall, when we did this, we had a dispose method and a virtual dispose method, right? This is the implementer of the interface, IDisposable.dispose, and then this is the virtual one that we built that actually has the check to say, are we disposing? If so, there's the if right there, if disposing, and then all the pieces inside. So let's extract these into two different methods here. So let's take this piece and pull it out. Extract method, build dispose method, like that. Oh, our preview hints are giant because we're dropped down. Let me do this instead. Let's go in to options. Ooh, no. I'm not going to do that because I just remembered. If I change the options and then I run, we'll have a slow startup time. So we'll just deal with the large preview hints for now. We'll just go back. All right, so there's my build dispose implementer. Like that. So I think I'll call that. And that builds that. That's cleaning up the code a little bit. This build dispose method goes essentially down to here. Okay, that's the virtual one. So let's pull that one out. Build virtual dispose method. I guess I'm okay with that. Yeah, that name. Dispose fields individually. We've got this piece right here. I think I probably want to take like this block out right here is what I'm thinking. If the field is IDisposable, then we're going to create some code right here. So let's go extract this method, pull it out of here, and this is going to be build field dispose block like that.
Now, just sort of, this may be some old ground, but in each of these cases we're reusing the same element builder, and internally we're calling add various objects. So would it not be more correct to say add these various things, since the current version of this code will be adding all of these objects into the element builder ready to churn out those objects?
I love it. Let's change it. So let's do that. One of my favorite things about CodeRush rename is if I select a portion of the thing I want to rename and I hit F2, it still stays selected, so I can just type in add like that. So it's nice. It allows me to, so add a virtual dispose method. Yeah, I agree with you.
So for those that didn't quite follow that, basically the element builder keeps an internal list, and when you say add something and you don't supply a parent object, it builds the object in question, so a method or an assignment or whatever, and adds it as a top level item in its internal list. Then you can come along later on and say element builder.generate code, and it'll find all the non-parented items in its list and start from them and generate their children. So you can generate 3 or 4 assignment statements maybe without necessarily putting a parent on them like a method, and then you can inject the code generated into wherever you need it to be.
So let's look at this. I just want to look at this piece right here. So element builder, we're adding the if disposing block. So this is the parent outside block. And then we're checking to see if the field is assigned. That's the piece that goes there. And then to that, this is the first parameter is the parent here when you see this add method call. So the parent is if the field is assigned, then we're going to add a new child, which is going to be basically a call to dispose, followed by, so adding a method call there, followed by adding the assignment where we set it to null. And that whole thing comes out of, so here's what I want to do though. I'm just changing the order of this around. It's not really a big deal. It doesn't matter. So I'm now taking if disposing block, add node, if field, because this piece coming in here, actually, you know what, I'm going to keep it. I'm okay with it. What I was thinking about doing is I was thinking about taking this whole thing out, extracting this, so we just get this, the if statement there. The if field is assigned when all its children. And then I was thinking I could reuse that. But for now, I'm just going to do it like this, because we can pass in this parent right here. Maybe we'll call this the parent if disposing block. And there's the field variable. I feel pretty good about this. So now we've got some methods that we can now maybe reuse. I can get rid of this comment right here. So we've got add dispose implementer, add virtual dispose method, then generate code. This piece right here, just for anybody who's new or needs a refresh on it, all this does here is either if there's only one location, if the whole entire class is empty, we just generate code immediately. But if it's not empty, we bring up the target picker, and then we call target picker start right here to actually start it so that the target picker shows up and we can move through it. Also, for anybody who's new to these webinars, full source for this is always submitted to the CodeRush community plugin site, which you can get to from DevExpress community plugins, usually within about an hour after we finish. Okay, generate code. Since we're now going to have two different code generation pieces, let's call this generate IDisposable implementation code, like that. Come on, get my fingers on the right keys. And let's also, here, this is a field variable. We're just calling this code. Let's also rename this as well to disposable implementation code. All right, so we just renamed that. And all right. So let's just run this, I think. And now that I've refactored, let's run it, and we'll kind of see what we need to fill in. We might need to start and stop a few times, but we'll see what's going on. Okay. So all we've really done is we've dropped on two issue providers. Let's go back. Two issue providers, code issue providers, and two code providers. That's all we've done. We've handled some events. Or I'm sorry, one code provider, which is dispose fields. So these two and this are new. Those are the three things we've added. And we've set breakpoints on all of these pieces. And what else? And we refactored. And that was it.
Okay.
All right. So let's open up Object Initializer Test. We should see a break. I'm expecting to see a breakpoint immediately. And here comes a breakpoint. So the fields should be disposed. So let's see what we're looking at here. So we've got the event arcs coming in. What I think I want to do is, so this is going to be an issue that's going to show up on the fields themselves. Okay? And so what we want to do is we want to essentially go through let's see here. We want to go through all the classes is what we want to do. So let's see where we have a get enumerable in here, and we can pass in a filter on this. So we can say ea.scope is the element that we're going to get the enumerable on, and the filter we can say a new. Do we have an element filter? So I forget what this is here. It's like language element type filter, I think is what it is that we want to get to. All right. And then we can pass in a language element type, and we want to look at all the classes. That's what we want to look at. Okay. And so there's our element filter. And that whole thing is going to, let me get rid of this so we can see more code on screen. And that is going to get us an enumerable that allows us to enumerate through all of the classes within the scope that we're being asked to look at. So for each I element, let's do this, element as I class element, and declare local. Go. And say if that's null, then we can come down and continue. Okay. So that gives us the class elements within the scope that we're being asked to check for the code issues. So at this point, let's just set a breakpoint. Actually, let's do this. I guess the next thing we want to do is check to see if this class implements IDisposable. So what we want to do next is we want to come in and we want to say, let's say go to iClassElement dot get base types. So this tells me all the types that this descends from or implements if it is an interface. And so we'll call get base types there, and let's get the let's declare that. So we have the base types, and then we will do a for each in here, and then there this is going to be iType element in the base types, and then we're going to say if item.name. In fact, let's just do this. Actually, let's set a breakpoint right here, and let's run it. Okay, we're here. Here's item, and see how far I have to drill in to see name. There it is, name. Object. So we can see that this class descends from object. That's one of the pieces that we want. Let's hit run and let's get to the next base type in it. And go do that one more time. One more time to get name. What? Still object? Doesn't make sense. Maybe I didn't. Let's add watch, and then we'll spot it. So there's object. Oh, you know what it was? It was probably, oh, you know what? We're probably in a different class, so it does make sense to what I'm expecting. Although this is the second class, which does implement IDisposable, I'm expecting. So now there it is right there. So that's what we're looking for. So what we want to say is something like this. We want to say if item.name equals IDisposable, then we're going to say implements IDisposable is true.
Mm-hmm.
And so now this will be able to tell, we'll be able to tell if it implements. In fact, I think I want to rename this to already implements IDisposable. Okay.
So in theory, are you saying we believe we're already in one that implements IDisposable, or we're not?
Well, what happened, I've stepped through this 3 times, okay? And here's what I believe happened. The first time, it was object. The second time, it was object. And the third time, it was IDisposable. So we saw that. So we saw 2 objects in a row. And here's what and in the file that we were in, there were 2 classes. So the first time we hit object, we were in one class. The second time we hit object, we moved to the next class. We're looking at that now. Okay? And the next class implemented IDisposable, but the first one did not. That's why we saw object, object, and then IDisposable. What happened is I only had the breakpoint here, but I didn't have any breakpoint here, so we didn't actually get a clue that we were actually in a new class.
Sure. Okay.
So
there's
it's a little
potentially alternative way of doing this as well. I believe it's a little more complicated in some ways, a little simpler in others. There's a primary ancestor type and secondary ancestor type. The secondary ancestors can only be interfaces. The difference is that it will return a list of iType element references rather than the
secondary
iType
ancestors. Oh, interesting. I've not looked at that.
.NET only has single inheritance. Therefore, the primary ancestor will be the real object, and the secondary one will be any interfaces implemented.
Let's see what we get here.
But as I say, it's a type reference expression rather than a type element, so there will be some further discovery needed in theory.
Interesting. So we count at 0.
0.
Let me come back up here and just hit the breakpoint here, and then we'll run it one more time just to double check. 0. That's the first one. That makes sense. Let's set a breakpoint here so we can see coming into the second one. Oh, this one says it has 2. All right, let me step through it.
Well, perhaps there's something not right there.
That's
Maybe I've misunderstood. Wouldn't be the first time.
Yeah, we'll need to look at that. So here we go, we're outside of that code. So, all right, so let's run it. And so here we've got this check code issues. I'm just going to run it. Check availability for disposed fields. Again, check availability. Check code issues. All right, so let's go and let's continue this working down in here. So now that we know that it already implements IDisposable, excuse me, then what we want to do is we want to go in, look at all of its children, and find all of the children that are field variables. And then for each of those field variables, we want to go in and we want to check to see if it implements IDisposable using that awesome .is call that we saw before, and you'll see it again here. So let's do that. So we want to come in and say, so I guess the first thing we want to do is say, like, and by the way, I think I want to say put a little to-do in here. Let's pull this out. Pull this out to its own method. This code right here that checks to see if we already implement IDisposable. Because that's like, you know, in fact, actually, I think I want it here. I want that pulled out. So we'll do that in a little bit. We can't pull it. We can't extract method while we're doing edit and continue though, because we're debugging right now. Okay, so so the next thing that we want to do is we want to go into iClass element. We want to get a call to, what do we have here? Get children call. No, we have an all children. Okay, property. Okay, so all children are there. Again, we're dealing with I elements. And like that. And so we'll come down here and say child as I base variable. They're local. And if it's not, so what's happening is we're going through the class, going through all its children. That means we're going to see methods, properties, nested types, delegates, and fields.
Yep.
So what we're doing is we're typecasting into a base variable to see if it's a field. And if the cast is not null, then we're going to continue, we'll come down here and be able to work. So if it's not null, we'll be able to come down here. Now, at this point, iBase variable, what I was hoping to see is a call to is that we could actually pass in IDisposable, like this, system.IDisposable. Unfortunately, that does not exist. Why? Because it's the interface, and the interface is what the light elements implement, and we had a big discussion on this yesterday, and I think we've done it elsewhere, so I'm not going to go back and do it. But the essence of this is there are heavy elements, and there are lightweight elements, versions of the same code. And so whenever you see us working with eyes in the interfaces, we're dealing with the lightweight version of it. If we want to go to the heavyweight piece that has more sophisticated methods and things like that, we can do that. And so what we do is we go into, we're going to use language element restorer dot convert to language element that gets us to from lightweight to heavy, and we're going to pass in iBase variable, and we're going to typecast it to base variable. Declare that local, and so now we'll say like if that's null, we continue, and now we can come down finally and we say if base variable dot is, there's that beautiful call, right? And it's got, I can pass in an iType element or a full type name. So let's do that. System.IDisposable. If it's IDisposable, finally, let's see, already implements IDisposable. Oh, we need to do a check on already implements IDisposable. So what we're interested in is something that looks like this. If we already implement it, then just keep looking at other classes. Okay?
Yeah.
What we're looking for is a class that, oh wait, this is field should be disposed. This code actually, I'm just realizing this code should be over in the, this one, class should implement IDisposable. That's where that should go. I just realized my mind was on one thing, but I was in the wrong place. Field should be disposed. So let's go, well, let's actually keep working. Let's do this. We'll just keep going because it's similar code. If we're not already implementing it, then just continue because we don't even care. Okay? Yeah. Wait, is that right? Hold on a second. See, this is the problem with sleep deprivation, sickness, and everything.
Okay, so this one is field should be disposed, which implies that we are already doing IDisposable on the class.
That's right. So
there
if we
are
don't
fields remaining.
Right. So if we don't implement IDisposable, we don't care. We're not going to look. But if we do implement it, then we do need to look. So I'll put a comment here. We do.
So it doesn't implement. It'll be the other code issue provider that picks it up.
we do implement IDisposable, let's make sure all the fields are disposed as well. ... Okay. So so now we have a base variable that is IDisposable. So you know what? You know what I want to do, Roy, because this is actually going to get really hairy, and the other one's a little easier. I want to do this. I want to take all of this that we just wrote. Is this going to be too? Everybody going to be okay with this? If I take this code and let's move it to the other one, and we'll work on that, and then we'll come back and we'll move it to the other one, implement it, then come back, then stop, refactor, and come back and build the second one. That's
okay.
what I want to do. You okay with that?
I've got an interesting question then, because at the moment what we have is we've got the code provider from last week coupled with the issue provider that is not coupled with it just for the moment, and we're going to switch over and have a matching pair.
Yes.
The interesting thing about this is, shouldn't they both have some code in common? Because they both have, one of them has check availability, and the other has check a bunch of stuff, again, to sort of, should I put a code issue up there? So there should be some common code there anyway.
I think you're right. I think what we'll do, I think one of the keys to doing this, right, since there's some commonality, is to start and stop, right, and do refactoring between. Find the pieces that make sense to pull out into smaller methods, and then build the second piece. That's what I want to do, and I think that my hope is that commonality will just kind of, bubble up to the top, and we'll see it.
Sure.
Okay. So what I've done is I've now moved this away from here. I'm going to clear out that breakpoint. I've now this new breakpoint here on this one, and we'll run it again. And now, so we're here. Class should implement IDisposable. So now we're going to do this. So the class should implement IDisposable. So if we already implement IDisposable, we're going to continue. Okay. So now it's the kind of inverse logic. That's why, see, this bit of code here we definitely need up in the in its own method, because we're going to see it in both places. Does the class implement IDisposable? Okay, so if we already implement IDisposable, so here we're going to change this comment. We do not implement IDisposable. Let's see if any of the fields. All we need here is let's see if any of the fields implement IDisposable.
So the interesting thing here is I'm almost certain that our existing check availability checks A, does the class implement IDisposable, and also already checks the fields.
Oh, you think we already have this?
Sounds like code we already have.
Oh, you might be totally right. So let's see if let's just do tab next reference and iType elements. Oh yeah, look at that. So on iType element, active class get base types. Okay. So this call to get base types, it's very similar, right, to what we saw before.
So the previous one gets base types and tests whether they're IDisposable, but apparently doesn't look to see whether there are any fields.
That's okay. It's just part of what we need, though, right? It's like this piece of code here is similar to the other one. So when we go out and refactor, we'll consolidate those.
Cool.
Okay. Manually, because there's no other way to do it. All right. So so let's see. Base variable. Okay. So let's see if any of the fields implement IDisposable. If base variables implements IDisposable, holy cow, we are available. Say that. And so we're going to come down here and say EA dot add warning, and the source range is going to be on the iClass element. And let's see, I'm going to take the first name range. So that's the name of the class is that's going to come back with. And let's pass in the IP class should implement IDisposable dot display name. Actually, not display name, provider name. Let's do provider name. That makes sense. No display name. I'm taking it back. If we don't translate, they're the same, but I realize if we translate, I actually want it to show up because this message shows up to the user. So we also have to, we need a to-do here. Hold on a second. Let me go into my final initialize plugin. We'll set a breakpoint here. Or actually, I'll just write the code so we can do this next time. So what we need to do here is we need to come in and say, what is it? Code provider dot implement disposable dot code issue message equals. This is how we tie the code. You can see that provider to the issue, code issue, by syncing those two up. And so what I'm doing here is the idea is that presumably there'll be initialization, maybe localization, but whatever that ultimately that display name becomes, that's how we're going to hook it up here to the code issue. Okay? So we'll do that. And there's another one too. We might as well put the other one in here. We have two. We have implement, I suppose we also have this one, code issue message is equal to IP dot field should be disposed dot display name. So there's that hookup. So that's not happening now, but it will happen later, the next time we run it.
Okay. We've got a quick question regarding the first name range.
Yes.
Is there any deterministic nature to where that will be? So in the case of a class that has partial parts to it, is that going to be the non-designer part, or, for example, is the code issue going to show up in the right file?
Yeah, I don't know the answer to that question. Send me Roy, send me an email, and I will investigate that, and we'll take a look at that. Let's see. I think there may be a clue in. So the answer is, I think yes. Okay. I think that if you have partials and one of them is essentially one that you work with in the editor, and the other one's like a generated version of the partial.
I think typically it's a dependent file as well, isn't it? The other ones they have this first file as their master in many cases.
That's usually the way it works, but it's also possible to do it in a completely different way for like a different kind of code project. So, but the answer is, I think I'm pretty sure for C# and VB, the answer is yes. That first name range is always going to come back as the class inside the file that you're in. But we can do some experimentation with that. It's not too hard to test that, right? Because you have files. So files, right? We talked about this before, but files gets an array of files where the element is declared. So in the case of partial elements, there might be several files. Then this XML comment goes on to talk about the name ranges, and files arrays. These are all properties that you can find in here. They're all synchronized, and they have the same length and indexes. So ranges of 2 corresponds to files of 2. It's just a way of finding out where things are. Okay. So what you can go
be able to find out whether the first name range's first file was the same as the file you were in, and if not, you could keep looking.
Yeah. So, but it's a good question, and ultimately, I think we're going to have to research this, have somebody look at the code, and see if it is in fact deterministic. I have a feeling it is because I'm pretty sure we are using this a lot through our refactorings, and so if there were problems with that, then our refactorings wouldn't work, and we would care about it. So we're available. We're available for what? This class. So now that we're available on the class, but we're in this for each right here, we can now break out of this. Oops. BR gives me break, and then we'll come loop around and look at the next class. So that's what's going on there. Let's run it. Let's actually step through it and see if we actually get to here. Let's just set a breakpoint here. See if we show up there. Nice. So let's run it, and let's see what we get out here. So here we are. There's the code issue. Whoops. Let's clear this breakpoint. Any other breakpoints we get as we come in here. Here's the code issue up here at the top. Oops. Class should implement IDisposable.
Cool.
Okay. So now that
will that disappear then if we comment out those two internal items?
What are you really seriously doubting the awesomeness? Okay, let's
no, it's always good to prove.
And back to check code issues. Let's clear the breakpoint and run it, and it's cleared.
There we go.
And if you didn't believe it, if you thought that maybe that was just a refresh, here, let's uncomment them out. There it's back. See it?
Sure.
I'll hover over to prove it's there. Class should implement IDisposable. Let's comment them out again, and it'll disappear. Okay. Is that hot or what? Well, it looks like we have a little display problem right there, but that'll I think as soon as I make a change to the code, it should clear up. So let me cut that. It's irritating me. All right, so there we go. So that's the code issue right there in progress. We don't have the fix hooked up yet, but it's just I think a rerun, and we'll get that hooked up. So let's do that. Let's shut this down. We're going to rerun, and the hookup code we already wrote at the top. I want to pull this out to its own method, this piece right here.
Yep.
Okay. So let's extract this method. call it already implements IDisposable.
For those rare few of you, like myself, who tend to do this in VB.NET, our ability to use edit and continue is a little bit better. We can do that whilst it's running.
Are you serious?
Methods. I'm very serious.
You can create methods in...
We can create and extract methods whilst it's running. The exception being is if we're using link. It can't do very good evaluation. Link has got some problems. You can't do that with link, but holy cow, that's awesome. Well, seriously, C# team, hello. Yeah, it's like I want to be able to totally just redesign everything. It seems like it's possible to do. All right, so we now pull this out to its own method. We have already implements IDisposable, takes in a class called iClass or an iClass element, and calls base tag. So let's go find that other thing that had similar code. And now let's come in here and do this. Already implements IDisposable, has an active class, and the code looks like this now. Excuse me. And this was to check availability for implement IDisposable. We can test to make sure that's still working. So let's run it now. See what we get. And I should, I'm thinking I should have refactored more. I think there's more we could have teased out. But let's run it and see what we get. So I think we're going to be at the, if this works, we are satisfying request number 1. Mm-hmm. Request number 2 is going to get a little mind blowing. So let's open this up, but let's see if we got essentially the essence of request number 1 satisfied. The reason request number 2 gets mind blowing is because we're actually now drilling into a method and analyzing the method to see if it actually is calling dispose on these pieces. So we're going to have to do that. So okay, here we go. So hover over this. What? No fix is available. Seriously? Let's see if the other thing is working. Come in here, and it's not there. What's going on? What's wrong? Okay. Let's go in here. Let's see what's happening here with our piece we're already at. Let's put a breakpoint here and see what's going on there, because that I'm expecting to show up. Hit the key. So this is an old code that we had. Equals already implements IDisposable, but we don't.
Was there a problem that I wasn't looking at?
Well, the name of the method, if representative, says available equals already implements IDisposable.
Yeah.
You meant not equal to.
Did I really?
Well, the previous version returned from.
CodeRush. Well, hold on a second. Let me see what's going on.
That's it, right there. If you look, the previous code says if equals IDisposable, then return, i.e. do not set available equal to true.
That's it right there. Okay, so let's jump out of that statement and let's put the not there. Oh, come on. Just give it to me. I jumped out. Trust me. So do what I want, right? So here we go. Let's come back in here and now run it. I gotcha. Thank you, sir. Roy, this is why you're here. Every time we do this, you like earn your salary in seconds.
It's just the whole pair programming thing, isn't
it? All right.
So one guy's coding, the other guy's looking. It all works out well.
So now we have implement IDisposable here. It's available. So the availability check's still working. Thanks, Roy. I really appreciate that. Let's see if we have the sync up now. If that made any difference on the sync up at all. I'm not sure if it would. There we go. Class should implement IDisposable. Well, by golly, let's fix it. And there we have it.
Sweet.
Okay? This is sweet.
That's good stuff.
I'm sorry, is this sweet? This is awesome. All right. So, okay, so that's step 1. Step 2, we need a code issue for this that's able to spot that, hey, blue brush is here, but it is not ever disposed. It's a little trickier. That means we're going to have to drill in and analyze this bit right here. You guys ready for this?
Yep.
Here we go. All right, closing this down. And, oh, you know what I should have done? I should have copied that to the clipboard. Let's do some refactoring. So we can kill this. This simplifies this bit of code.
Okay.
And, oh, we got an extra semicolon right there. All right, there we go. Remove block. So that's nice. I like this. That availability check is simplified. Already implements IDisposable. I'm also going to do something that I like to do when I wrap up a method and I say I'm done with it. I like to just embed it in a region. So when I have a nice small method, I say, okay, that's good. And so we can kind of collapse some of these pieces up here a bit. And here we go. Yeah, this is good too. Just get things a little bit smaller. All right. So that hookup code is working inside of the initialize. These are the methods, and it's already selected. We can close that one. We wrote that last week. Okay, so fields should be disposed. Let's look at this. Let's see if there's anything else we can do inside of here. I think I'm going to just copy this and modify it. Is what I think I'm going to do. Oh, wait. Class element. Already. So this is all. That's all actually pretty good. Yeah, I'm going to copy it and let's modify it. Makes me nervous to do this a little bit, but let's see what we end up getting. And if we see commonality, we can refactor later. So now we want to see fields should be disposed. So now we want the field should be disposed if let's see. Field should be disposed.
If we do implement disposable, but some of the fields are individually not being disposed.
Exactly, right. So if we don't already implement IDisposable, we don't even need to check any further. We only need to check if we do implement IDisposable. So now let's check, let's make sure all the fields are disposed. Okay. So we're going through, we need to check all the fields. Now here's what I want to do this time.
All the disposable fields are disposed.
Exactly. So let's take out this. And now let's come in here and we'll say something like disposable fields. Let's collect them. What I want to do is collect them. .add, we'll pass in base variable. Let's declare this. Oops, I want to declare it locally. I give it a few, this is my syntax for fields. So we'll do that. Let's pop this up here. And we're going to say that's equal to a new list of, copy that to clipboard, there, new list of base variables. So those are all my disposable fields. And so if it is, we're not going to break now. So if it's disposable, we're going to go. Let's change this to if it's not null, then we're going to go do all this code right here. Okay, so if we're a base variable, the reason I'm doing this is because we're going through all the children. I want to see if any of them are base variable, but I also want to find that virtual dispose method so I can then look inside of it. Does that make sense?
Yep.
And then what I'm going to do, since I'm collecting these disposable fields, right, here I'm just adding them right there. What I'm going to do is I'm going to check to see if I can see that those fields are being disposed. If I can get general, relative certainty that they're getting disposed. If they are, I want to pull them out of this list. And then at the end of all that, I want to see if anything's left over. Make sense? And if anything's left over, by golly, that's what we're going to be available.
Sure.
Okay? So, all right, so there's my disposable fields. And then the other thing I want to do, let's just do this. I want to say let's run. And then we'll come down here. We'll just create an else in a block, set a breakpoint here so we can handle that, find that method. Find the virtual dispose method. And then, yeah, I'm going to say let's run. Got a breakpoint there. I just realized I shouldn't sing on the professional version of the webcast. All right, I seem to be, with your help, Roy, I seem to be doing not too badly.
Yeah,
I'm going to grab a couple cashews and give myself a little protein here. Do we have any questions, by the way, Roy?
No, although some of our listeners have spotted the missing exclamation point on our previous issue, so I was not alone there. But no, we seem to be following quite well.
The missing exclamation point? Oh, you mean on the not? Oh,
yeah.
Gotcha. Okay. All right, so here we go. We have a new child. What is this thing? It is
simple type reference expression.
It is IDisposable. Oh, this is all children. Okay. So all children. So let's, whoops, I wanted to get that in here. Hold on a second. IBase variable. Let's do this. Let's just say, come in here and we'll say child as I method element. If not null, we'll set a breakpoint here. So at least we'll start looking at methods. So I was going to say this. All children actually gives you access to not only the nodes but the detail nodes as well. And what that means is, let's bring up the expressions lab. We're talking about the difference between the detail nodes and the child nodes. So if you bring up the expressions lab, you see some of the nodes are in blue and some are in black. These are detail nodes. Notice where they show up. They show up in this for each inside the expression, whereas the children are the actual statements of it, like this. And so when you go to all children, you're actually going to see all of these things. That's why that first one we hit, Rory, was IDisposable. It wasn't a method. It was actually one of the elements that this inherits from, I believe. So that's what I think was going on there. So at any rate, we'll keep running until we see a method. Now let's see what the method.name is. We're looking for something called dispose. Oops, name. Properly dispose resources. There's the class name. No, it's not. That's a constructor.
No, that's a constructor. Yeah.
Thank you, Rory. Let's run it again. Initialize brushes. Oh, that's that other method. Dispose. Okay. So what we want to do now is we want to say if this and element.name equals dispose, then we're inside of here. And then what we want to also do is we want to check to see and this dot is virtual. No, wait, what is it?
There's been an interesting point just brought up as a question. It says if there was an all field at all methods, thing could be a bit simpler. And technically there is. There is on the fully fleshed out version of the class.
Yes.
However, we've got to remember that when we are doing code issues, we potentially have the solution-wide code issues on, which will mean that if we were to automatically rehydrate to a class, we'd be doing that potentially for every class in the entire solution. So this could be looked on as an optimization, like we talked about yesterday. Using the light methods where we can get away with it is the more performant way forward.
Right. So to demonstrate what Roy was just saying, oops, on my class. So the lightweight one, we're using this iClass element, which is just here. It's the lightweight one. But let's say we wanted to make it easier on ourselves. We could do something like this. Let me execute this line of code. And now my class, actually I didn't need to execute it, but it's now got a all fields, all members, all methods, properties, they're all there. Yeah. Okay? So we could do that instead. Where
we had to hydrate the entire class to do it rather than just sort of the outer skeleton. So potentially there was a more CPU intensive mechanism to achieve that.
Oh, sorry, Roy, I just muted to cough. So yes, you could do it in that way that was suggested. Oh, guys, great news. I have a cough drop that I brought just for this occasion. I'm so prepared because I knew we were going to be like, it was going to get intense. Okay, here we go. Cough drop is ready to go and now effectively working. I wonder if I'm going to sound like I'm eating the whole time. Okay, so is virtual. Notice this one is false, right? This is the first dispose method. Yeah. Right? We're looking for the one that is virtual. Let's run it. It should hit it next time. There it is. Is virtual is true. Okay? Let's come down into here. iMethod element dot all children. We can do it again. And we'll come in here. iElement element. Or wait, do we already have an element in here? I think we do. We'll call this potential statement. Call it that maybe. And then we'll say potential statement as an if statement. Clear that. If not null. So now what we want to do is we want to check to see if the statement is checking to see if is doing that. We're looking for something that looks like this. If disposing That's what we're looking for, this block, okay? So let's get down to here. We'll set a breakpoint here and see if we get down to this point. And we do. So we found an if statement, all right? So let's go in here. Let's see what we got inside of here. We've got something called condition. The name of condition is disposing. That's the expression. So what we can do is we can say if it's not null and statement.name equals, well, I can just type in disposing. That's the variable name that's passed in. That's the parameter, I mean, that's passed in. However, method element dot parameters. Let's see what the count is on this. Expecting count to be 1. There it is. This is also something we could check as well in our test for this, right? We could come up here and we could say and the parameters count is equal to 1. We want one parameter going into that. Then we found it, right?
For those of you looking to do language agnostic plugins, you've got to be very careful here because in your generation code, on the other flip side, you may have decided to use whatever the settings are in order to name the field, which means you have to check for an upper lowercase or preceding. So you might want to effectively send this through the same, would it be local or a field? I forget which. But
we've already got the field name, Roy, so we won't have to do any special naming because the fields are already there.
I was talking about the word disposing.
Oh, right. Well, I'm getting rid of it now. I'm changing it to parameters of 0 dot name. Let's see what that's equal to down here. Come on, there it is. See it?
There we go. Yeah.
It's awesome, isn't it? Okay, so let's put the code back up here and run it. And, oh, we didn't get into it. Why not? If statement is definitely not null. What's going on here? Whoa, if statement.name. Oh, it's not if statement.name, it's if statement.condition.name.
Ah, yes.
Now I'm going to put back up here again. Step. Now we're inside. Okay? We have found if disposing block code. Now we have to go one step further. We have to go drill into that, and now check to see if we can find. Well, actually, you know what? For now, it doesn't matter. For now, what I'm going to do is I'm just going to say this if statement piece right here is going to be. We're going to say the parent if disposing block if disposing equals the if statement, like that. Let's declare this locally. Let's put this up out here. Oops. Let's set it equal to null. Okay. And then let's break out of there. We don't need to be in this for loop anymore. And then we also want to check here if we want to say if the parent is disposing equals null. So we're still trying to find that parent if disposing piece. Does that make sense, Rory?
I think so, yeah.
Okay, now, once we finish going through, we found this, and we've gone through all the children and identified all the base variables that are implementing IDisposable. So we want to get out of this for each block. So I'm going to use selection increase and just right arrow to get outside of it. Now we should have these two properly filled out.
Okay.
Let me show more code here. Let's get rid of this so we can see more code. So now what we want to do is we want to say if disposable field is null or parent, wait, it's not null. This one is null. If it's null, or this one dot count, because this one is count equals 0, then we want to just say we're out of here, completely out of here. Okay. Otherwise, what we want to do now that we've collected, so you see what I'm doing? I have this loop that's just collecting things, and now we can work on those now. Now we can go into the parent if disposing and check to see if any of those fields is actually implemented inside of that. Okay. In fact, what I really want to do is I want to pull this out into its own method. So I'm going to do another to-do reminder here. Pull this out into its own method. For this big block. Okay, so I'm going to take all of that out because I want to. I essentially want to do. Actually, let's change this a bit because I want to actually now. I want to. Let's change this to and this one is not null. And let's do this. Let's go inside here, create a nested block, and so now I want, because I think what I want to do is actually take everything above plus the thing I'm about to put in here, the code I'm about to write now, and I want to pull it all out. So now what we need to do is go into that if statement. So let's set a breakpoint here and run. All right. So now we have a count of 3. We have 3 disposable fields, and we've got this parenting if statement. So come in here, let's go into all children, do a for each on that. By the way, Roy, I've noticed this a couple times, this is absolutely wrong. Base variable keeps coming in, and I'm not sure why. There's clearly a bug in the piece that's determining what all children are supposed to be enumerated by.
Sure.
Can you just make a note of that and have the devs watch the video? Okay, so
No
we have
problem.
I element, and this is going to be the child if, or no, the potential child if is what I guess I'll call this. Potential child if, and now what we're looking for is, let me just run so I can show you in the code on the other side. Clear that breakpoint, clear that breakpoint. All right, we're looking for, so we've found the if disposing, we're now looking for if this is not null, right? That's what we're looking for now. If we're over here and I bring up the expression lab, in the code we're working on, in the second instance Visual Studio that we're testing with, and we come over here to this piece, what do we get? What does it look like? Well, here's our if block, and inside of that we have a, wait, hold on a second, I think there's a property called, what is it expression or condition? Let's see what we got. Condition. So we have condition is here, and the essence of this is that we can drill into this and look for an identifier that says red brush. So the condition is here. The condition is likely going to be this relational operation.
Yeah.
The relational operation, the first child of that is, or one of the 2 children, because you could reverse this around and we still should be able to work, right? One of these 2 children is going to be null, and the other side is going to be null reference. The other side is going to be matching the name of what we're expecting. I'm sorry, not what we're expecting. I mean matching the name of the field. Okay, so let's go back over here. We have this now to re-invoke this. We need to make a change in here somewhere. So that should make a change and get us over. Okay, so we made a change. We're going back in, checking again. So now we want to come in here and see if we have. If we've got a potential if, and what I want to do is come down here and say potential if as I if statement, clear local, and this is going to be we'll call this the child. That makes sense. We'll call this the field not null statement, even though it's a bit presumptuous at this point to tell that it's in fact that, but we'll see what we got. And then what we want to do is we want to say, if this is not null, then let's go in here. So we'll go hit F10, and whoops, it's null. Oh, you know why? Because that's the comment. The first one is the comment. If we were to go in here and drill in, whoops, let's look at this again. Element type, element reference expression. Oh, it's an element reference expression. Does that make sense to me? All children. Oh, we're in all children again. This is not the same thing as statements. So this is the first reference, which is inside. This is that disposing piece again. So that's okay. We're going to keep going. and now we finally hit it right there. So there was a comment as well, and I think we skipped over the comment, and now we have condition, and condition is a relational operation expression. So let's do this. Now that we're in here, we'll say this dot condition as I relational operation expression. Declare that if not null, and then we're going to say if this dot left side dot name equals the field we're looking for. Now, let's do it this way instead. Let's say if disposable fields dot contains base variable. Shoot, it's a base variable. So I guess what we're going to have to do is we'll kind of have to write our own disposable fields piece. Is that what I should do? Or should I have instead added these as strings in the list? Let's do this. We'll just write our own. So we'll just create I have disposable fields there. For each disposable field in there, and we'll say if disposable field dot name equals the left side dot name, or say the right side. Do I have right side? I don't. Yeah, I do because it's a relational expression. Then here, at this point, I'm going to say safe to assume. However, if you really wanted to verify, you could continue to check for a dispose call in the children. It's like one more level deep, but you see what I'm saying, Rory? I'm going to say, look, it's reasonably safe to assume that we properly dispose code.
There's also, given the nature of the other pieces we've created already, it's relatively safe to assume that, well, it's not a certainty, but in a large number of cases we will have created this dispose mechanism by running our previous code provider, and we know the structure that outputs.
That is also very true. Yeah, and you know, that's the thing is I was looking at that and I was thinking, could we just make some assumptions and just like maybe just do a search for all references, you know, just iterate through the references and look for that name, and ultimately I said, let's do some code exploration. Let's look, in other words, structural exploration. So now we're going to come in here and say disposable field, no, not disposable field, disposable fields dot remove, and let's remove this disposable field. Okay? Why are we removing it?
We found it being disposed, therefore we don't need to add a disposal of our own.
Yes.
And we can remove it from the list of fields that effectively we are going to need to add disposal for in a moment.
All right, so now, let's see, let's get outside of this. If all of this works correctly, at this point, we should have a list of disposable fields that are not disposed. Okay? And so, let's see, what do I want to do here? I want to say, let's do this. Disposable count, I want to change this to greater than 0. So let's come down here. So if, whoops, disposable count is greater than 0. At this point, we are available. Let's run and see if we get here. Let's clear the breakpoint. Clear the breakpoint. Breakpoint. Okay, count is 2. Sweet. So at this point, we're going to say available. I just want to go up. Oh, this is the code issue, so we need to add a warning. Okay. And at this point, we're going to put the warning on each field, I think. So let's come in here. So for each disposable field, we'll come down in here and we're going to say ea.add warning. The range is going to be the disposable fields dot name range. That's the range of its name. And the message is going to be IP field should be disposed dot display name. And let's run it. With a breakpoint and run. Hover over.
Nice.
Field should be disposed. Okay. Nothing's available because it does the availability check on the other piece and it's not coming back as available. So we have to now do the next part that actually writes the code to fix it. Okay? A little bit mind-blowing, but we're almost done. The next part's kind of big too, but we're getting much closer, right? Check. I mean, this is really awesome. We have IDisposable. We've added some pieces that implement IDisposable, but we're not cleaning them up inside the code, right? In fact, again, Rory, if we, your question might be, well, what happens if we go in and make changes to the code? Is it going to be able to get all that? Right? If I copy this to the clipboard, come down here, come inside of here, grab blue brush, put that in place of it, like that. Now, are we gonna? Oops, there we go. Let's count 1 now. It's 1. Hit run. Now up at the top, we see blue brush is okay, but orange brush is not disposed. And so what we did, just so everybody understands what we did, we looked for this. Well, actually, we looked for this, right? We were looking for all the fields. So the fields can be anywhere, right? We looked through all the children. We found all the fields, implement IDisposable. We found this method, right? We're looking, is it virtual? Does it have 1 parameter? And is it virtual? And it's called dispose. And then we check to see, does it have an if block that has an expression that matches the parameter name? And if we have that, then we look through inside of that, and we looked for statements that look like this, and we check to see if the left or right side had the name of the field variable in it. If it did, we removed it. And what we were left with is simply orange brush, which was not referenced inside of here. Okay, so that comment I was talking about was saying you could go one step further and actually look and see if we have a proper disposal in here. Okay? All right, so let's clear this out. And now we want to add code that actually pops it in here. I'm going to, let's go ahead and shut down this instance of Visual Studio.
It's worth noting with a check code issues that you have no way of knowing as the coder what the range will be that you'll be searching through. That's effectively controlled by the DX core and how it calls your provider. Yep. As such, you've got to be very careful of any exceptions that get thrown, because you might throw an exception due to object reference not found. Maybe you haven't checked something correctly early on in that range, which means it won't then go on to search later items. It'll kick out of this method altogether, and that will be eaten by the DX core in order to preserve its own stability.
Great point. When I was practicing...
There may be a point in here I spotted earlier where we suffer that. If you look a little lower, if statement.condition, a little higher than where your cursor is not checked to be null. You could effectively have an if bracket bracket.
I see. Good job, Roy.
Isn't necessarily a disaster, but again, if you're looking for a long chain of items, maybe you're doing a full solution-based thing, you'd only find a couple of those and then it would kick out.
Yeah, good point. Also, when I was first doing this and I was practicing, I made the mistake of doing this. So what happens is, if there's multiple classes in a file, it would find only the first one, whatever, well, actually it wasn't here, it was in another location, but I used a return instead of a continue. Because I was kind of like, okay, well, it's not what I want, it was like here. Is it, or no, it's here. I did a return. That's where I put it. I actually spotted it in the code without seeing the bug beforehand, but, which is not, great when that happens. Okay, so I want to pull out this big block into its own method. And I want to grab from here down to here. See if I get a clean one here. I have one return value, one input. I'll take it.
One in, one out. That's good.
And CodeRush gives me a good name for it. Get disposable fields. Okay. And there we go. So we have that. Let's clean up these just so we've got to compress a little bit. Now let's go in and let's work on the check availability. So to check availability, I'm just going to grab this code here. So let's see. This is going to be ea.element as iCloud. Oh, actually, not element. Okay, so element is the element that's at the caret. So if I'm here, for example, the element that I'm at is going to be like this type reference called object. Let's go up here. if I'm
And this is the
here,
mistake you make. If you're used to doing pure code providers and you've not been doing code issues, you'll have maybe thought this was the right way to go. But as Mark says, this is where the carrot is going to be. And there is no carrot when code issues are being declared, as it were, or looked for.
So what I was getting at, though, is I want to use class interface or struct is what I want to do, which allows me, if I'm for example, here, to instead of coming and getting this reference back, I get this essentially reference to the class. So if I'm here, it gives me the reference to the class. So that's what I'm looking for. So this as an iClass element. If it's null, then I want to return. If we don't already implement it, then I want to return. And then here, I want to say, if disposable fields count is greater than 0, I want to say ea.available equals true.
Yep.
I also have apply and prepare preview. And what I need for prepare preview is I need some code to be generated. And what I like to do is, since I'm already kind of doing some work here, is I like to actually generate the code here. So hold on a second. Let's get disposable fields. Parent if disposing. I want to pass this out as well. So let's do this. I want that. Did I nail that? Did I get it right? Oh, it's an out parameter. All right. So there's parent if disposing coming in there. That's coming in as an out parameter. So it's actually, we do need to set that to the beginning, and then that should make us happy. Okay. So the reason I want this parent if disposing, so that's that block that goes, let's do this. That's the block that looks like this. It says if, disposing, and then it goes from here to here. That's what I want to pull out because I want to work with that. That's what I want to work with. So now I'm going to come in here and I'm going to say out, oops, out, parent if, local, and so now we want to do, we want to generate some code. So yes, we're going to be available, but let's actually generate some code here in the availability check, and then we'll use it down in the prepare preview. We might also, if you really want to, if you're really concerned about performance on the availability check, you might not actually generate code here. You might instead just cast out, for example, the disposable fields, so that we come into the prepare preview, we can use those, or you might just say, okay, I just want to call this whole thing again, because it's probably not going to take that long anyway to make that call, and just call it again in prepare preview. So at the very least, in prepare preview, it's a good idea there to cache out and generate the code. So what is that code going to look like? Well, first of all, we've got this parent if disposing piece that we need to work with. The second thing is we have that method from last time. This one, add field dispose block. This actually adds that block of code. So what I want to do is I want to say take that parent if disposing and I want to clone it. And what this is going to do is it's going to clone it and all its child nodes so we can regenerate that code. And I'm going to declare that as an I if statement. Declare that locally. This is going to be our new if statement. It's going to replace it. Then what I want to do is make this call add field dispose block. I need to pass in an element builder, which I don't have yet, but we'll make one up. We need to do the parent if. Well, now look at this though. It is saying it wants an if block is what it wants. So where's my parent? So let's do this. I think what we're going to need to do.
That's the parent if disposing, isn't it?
I'm sorry. What? Say that again.
Is that the parent if disposing that we got out of the get disposable fields?
Yeah, it is. Let me. You know what? Let me do this. Let me go in to this piece, and I just want to look to see if I can simply, so we have called to add node. I think I can change this to an I if statement. And let's see if we have add node. Oh, we don't have add node in there. So, all right, so let's not do that. So let's go back into make it an if piece right there. So what we'll have to do is we'll have to rehydrate this piece right here that we can get back. We're going to come down in here. We're going to say, so back again called language element restore. Convert to language element. Pass in that as if. Right there. Declare local. This is going to be the if parent. And then we're going to say the new if statement is going to be that piece.clone as an if. All right, so now we're down into here, add field dispose block. So now we need the new if statement. So what's cool is this. Look, we've got this if disposing out there, right, with all of its children. All of its children, which are simply if red brush is not null, if blue brush is not null, that sort of thing. All the children are there. So those child nodes are already there. So when we go into add dispose block, let's fill this out. The field is what we need next to put in here. All we need to do is this. We need a for each on the disposable fields. Okay. And inside here is where we need to put this block of code. And so we're going to say the disposable field. Pass it. And this is just going to add these to the end as child nodes. Okay. We need to create a new element builder. Okay. Let's put this here. And I think that's it. So now we're in new episode. Go ahead.
Just because this is getting a little bit mind-bending at this stage. I just want to reiterate what we've got, just to be sure that I understand what's going on.
Sure, go ahead. That's
okay,
awesome.
So we're going to get disposable fields, which is going to return us a list of, I guess it's disposable fields that have not been disposed, strictly speaking. Yeah. It's also going to pass out the parent if disposing. So that's literally the if statement that says if disposing. It's the larger one around the potentially multiple disposing fields there. So why is it that we're then cloning that if statement, since the ones we're going to build are going to go inside the original one?
Well, because we're cloning because it's a good practice when we're generating code. I believe you could actually get away with this without cloning it, okay. Because we're adding to the piece and we're going to immediately destroy it. Well, wait, this is check availability. So no, we do not want to do it here because if we don't clone it and we go into element build, we go into this method, add field dispose block, go into element builder. Element builder add method call. This actually is going to create a child node called method call of type method call and add it to the field as assigned block, right? And then it's going to take that field assigned block and add it to the parent if disposing block. So if we don't clone it, what we're actually doing is altering the parse tree from our plugin. Sure. Which can cause availability problems and all sorts of other things. So we need to clone it here. So that's why we're cloning, because we're about to generate code on it. So we're cloning this new if statement, passing it in here, right there, and what's happening is it's here now, and then we're calling add node on it right there.
Okay.
So we're doing that.
So we've got a brand new if statement, which looks like the if disposing that it had before, and inside of that we're going to add multiple calls to dispose for each of the fields, and obviously their own if not disposed statements around that.
Yes.
And then that's the piece that we're going to. So what do we expect to come out of this generate code?
Well, let's set a breakpoint and find it. But before we do that, let me widen the scope on this. So this is the generate code. What we expect is we expect to see if disposing, and then it all properly filled out.
Sure. But that will be for the remaining as yet undisposed disposable field. So if we had red, green, and blue to start with, and only red was already being disposed, we're now going to get an if disposing with the blue and the green in it.
As well as the red.
Ah.
Any code that was here before.
Oh, true. Yes.
Will still be here because of the clone.
So we're not adding inside of the existing code. We're going to replace the existing if disposing with this new one.
You are correct. I should have pointed that out at the beginning. I actually considered doing the alternative, which is finding the right spot and generating just those pieces and adding them. But I realized that I was going to have problems where that could easily be solved for me if I just did it this way. And as an example, sometimes, you know, if I don't need braces, for example, I can have code that says here, if red brush is not null, then block here, right? So there's no braces here. So how do I insert code there? Well, I'd have to check to see, I'd have to add all this code, Rory, to check to see if it had only one child statement. And if it did, then I need to add my braces and then figure out where I need to put my new if blue brush.
Yeah, it does get considerably more complicated that way.
It gets really complicated. But instead I realized, oh geez, I'll just construct the whole tree and replace the whole bit and then let CodeRush figure out what I need to do. The DX4, I mean, right? So code for new if disposing block is here. I want to widen the scope. And so now, whoops, I'm sorry, not that widen scope. I want to do widen scope promote field. Code for new if disposing block is there. The other thing I want to do is I've got a prepare preview down here. So the prepare preview, let's go ahead and start writing some of that code. EA.add code preview. This looks for two things, a location and the code. Well, the code is going to be what we just generated. Code for new if disposing block. By the way, if anybody's like barely hanging on here, their mind is almost blown, it's about to get really awesome if this all works. Hang in. We've only got, I think, maybe 10 more minutes, and it's going to go. By the way, if you're watching this pre-recorded and you're looking down at the progress bar and you're laughing because it actually shows another 4 hours to go in the recording, I don't know, I guess that's nothing I can do about that. No, I think we're going to get done in 10 minutes. I think we'll be done in 10. So, all right, so we need to find out the location. Where are we adding that? And the other thing is we need to delete the old node, the old if parent. So what I want to do is I want to come into the old if parent and I want to go grab its range like that, and I want to say let's declare a what's going on here? What is happening here? It seems like there's a code formatting problem here somewhere. Because when I came in here and I hit enter, it popped me in the wrong spot. Oh, I see, because it's we had a problem before because I didn't have a semicolon, and that's why it was a little bit off. All right, so we want to come in and we want to say if parent.range, and let's declare a local for that. We're going to call this the delete range, and let's widen the scope as well. Promote that to the field. Let's give it a better name. I decided this is the old if disposing block range. Do that. So we now have the code and we have the old range. So now down here for the code preview, we can say the place we're going to insert is going to be block range.top. So that's the top of the range. So range is like a selection. The top would be the thing closest, the point closest to the top of the file. So that would be what this points to. Okay, so that's step one. The other thing we need to come in here and do is we need to add strike through for the for that old whole range. And I'm going to set a breakpoint on apply. So we get here. We'll just go do this and run. Okay, let's run. Awesome. No errors. Not awesome. I don't have another cough drop. I'm coughing again. Object initializer test. Let's open it up. Looks like Amanda said, if you can't take any more, watch it all later at tv.devexpress.com. Thanks, Amanda.
Nice amount of faith there.
Thanks for the faith. Okay, so let's come in here. Let's do this. Let's hover over it. Nice. See that? We have the link. It's hooked up because it's available. The availability check is going. If I click on Disclose Fields, we're just going to hit that breakpoint. Nothing's happening yet. We'll go ahead and run it. let's come down. Let's
We
be
could use
here.
the code provider and see the preview though.
Yeah. Bring this up. Dispose fields is available. Oh, we don't see it because it's not on
Because it's a
screen.
little off screen, yeah. Okay, well.
Let's do this. Oops. It thinks I think I hit enter on it. Let's try it again. Okay, here we go. There you go. Oh, what's happening with our code? Code's not happy. Why is our code wrong? Set a breakpoint here. That was true. Generate code. It's definitely empty.
Right, so I'm curious about this. I was having a little discussion with Alice Stalking the other day, and we were having a question-answer session. It was my understanding that the element builder, when you say generate code, will look through its internal list for any items that do not have a parent. Okay? And so the cloned if that you gave it is not inside the element builder.
I'm putting it in right now.
There you go.
I think it's exactly the problem. So let's come back up here. What? What? Well, it needs a parent. So this will pass in a null, and I bet this will fix it. Okay, so we'll come in, run step. Oh, come on. Just run step. There we go.
There we go. So just again to reiterate, the element builder only tries to generate code for items inside of itself with no parent of their own, and obviously it'll find all of their children. And when it went through the first time, all of the things inside of it, the dispose stuff, all had parents, so there was nothing left to generate. So what we did instead was pass the parent if statement in, added that, which, since we cloned it from somewhere else, doesn't have a parent of its own, and as you can see, there's the code.
Now, I want to point out something really awesome. See that? Free managed resources, it's a comment, it's part of the original, but it's there, right?
Yep.
This bit is not generated. This part is cloned. This part was cloned. We just added children to it, and we got these pieces automatically. It's awesome. Let's actually do the final step, which is generate the code. So we'll come in here, we'll say, we'll go into event args, dot, text document, dot, what do I want to do? Let's do a queued delete. So these queued calls to it allow us to queue up several things and operate them all in one step with a single undo operation around them. So we want to delete, what do we take? A range. So the range we want to delete is the old disposing block range. We want to come up here and we want to queue up an insert. The insert is going to be the new code. Oops, it needs an insertion point. That insertion, whoops, the insertion point is going to be the top of this. Dot top. Here's the code for the new disposing block. And then we're going to call ea.textdocument.apply queued edits. And the operation is going to be dispose fields, comma, and format is true, because we want to format everything. And I think that's it. Could it be that easy? Let's see.
Could be.
Look at that. Code issues go away. Let's undo it. Code issues should come back. There, it's gone. Code issues are back. Let's hover over it. Click. Boom.
Yeah. And just to draw more attention to what you just mentioned a few minutes ago, that comment there, the free managed resources, that would apply to any custom code that was in play. Mark's very generously not drawing attention to the fact that I'm on IM here going, you're about to hose somebody's code. No, he's not, because basically CodeRush is handling all of that behind the scenes. It's going to preserve everything that was there before and add the new pieces to it. So very well done.
Awesome. Okay, I just want to say, I'm going to say, James Counts, this is awesome. This is a great suggestion. It's incredibly powerful now, right? And it's helpful too, right? You get this on things, now we know, everybody knows, solid brush, okay, it implements IDisposable. But there are a number of .NET classes that implement IDisposable that's not obvious just at face value, right? And especially for new programmers, this is going to, I think, help a lot of people out. So James, sincere thanks for that suggestion. Anybody else that's listening or watching, give us more suggestions. We are rocking and rolling. I got a suggestion, by the way. Let me see if I can bring this one up for what's going to happen, I think, next Wednesday. Let me see if I can find this one. Hold on a second. Give me a moment. And Oh, I'm not finding it. It was from Joshua. I forget his last name. I'm trying to search.
Yeah, I remember the one you're talking
Joshua
about.
Poles was his name. Let me see if I can bring up his page here, what he was talking about. Hold on a second. Oh, he's talking about something that he wanted. He wanted to have something that says, hey, what if you're here, but you're not actually implementing that interface? So I'm thinking about doing that for next time. So next week, that's a possibility we'll do that. I'm not promising it. We may do something different. But the idea is it's going to go through all the interfaces and then make sure all those interfaces are actually implemented. And if not, allow you to add the code to implement them. And guess what? We'll actually add it in a way that doesn't do stupid things like create properties with just throw new exceptions in it. We'll try to create it in a, if we do it. I don't want to overpromise this and talk about how awesome it'll be. Because we've got a week to decide what we're going to do. We may choose something different. Sure. And with that, Amanda, or do we have any questions for you?
Just checking. Just checking that.
And you know, while you're checking, there's one other thing I wanted to show everybody, because this was a question that came up last time, and the question was, how do I get a Boolean literal? How do I generate that code? And let me show you that bit right here. We actually use it. We used it last time here in implement IDisposable. Boom. We used it here, dispose true, right there, passing in the word true. And the question is, how do I get a language independent version of that? We actually have an answer to that, and I'll show you that just real quickly, so anybody that was watching the other one can see that. So let's close this down. And let's go back up over, let's search for the word true in quotes. So for when we built this piece right here, it was not too big of a deal because Visual Basic, when we called format, it actually turned it into an uppercase T, so it wasn't a big deal.
That's right.
However, to make this truly language independent, you want to use a method that looks like this. This is get Boolean literal, pass in a Boolean value. Check out how it works. We create a new primitive expression. We say the type, what the type is going to be, and it can be any of these types. And then we set the primitive value to simply what that value is. Once that we have that, we can now come in here, we can say get Boolean literal, pass in true, like that. Let's declare local. So this is going to be our Boolean true, like this. And now instead of passing a string array in here, the other option to add method call is, well, we can do a collection of arguments or a source. But the source we don't need. So what we want to do is the collection of arguments. So we need to say a new expression collection. Those are going to be our arguments. Let's use selection increase, declare a new local for that. Wait, why can't I get a local on that? That's odd. And this is going to be null for this next piece. That's really odd, and I'm not able to see that. There we go. Introduce local. Maybe, oh, you know what? I was looking at the wrong menu. Okay, and so this is going to be these are the arguments. Is that right? Yeah. These are the arguments collection, and then we can just say arguments collection.add and pass in our Boolean true. Now if we run that, that should work and give us a true that's language independent. So that's how you do it. It's pretty cool. Now
we're useful as well. You could probably get away with using dates and use the exact date formatting that was particular for a language. That's always something that eludes me. I never remember that. In VB you put hash marks around the date literal.
Oh, okay. All right. So here we go. Let's open this up and let's just verify that that works. And then with that, we're going to say done in 1 hour 40 minutes. It's intense. Thanks everybody for staying with us so long. Okay, so we're going to come in here and just see that that word true is in fact coming in lowercase. IDisposable. There it is. You can see it's lowercase right there. So that's the answer to that question. Do you have any other questions, Rory?
No, just lots of comments about how awesome this particular session has been.
Great, awesome. I love that you guys stuck with it. Rory, I'm going to get you the source code within minutes. Get this up there. We'll. I'm going to get some lunch, so I probably won't blog about this for a while, but I'll try to blog about it before I end my day today, and we'll talk about it. And you guys can tweet about it too. Tell people about this awesome plugin. And I'm almost positive we're going to roll this into 11.2 because I really like the usability of this.
It's nice, yeah.
Okay, Amanda, get us out of here.
All right. We have a whole line of webinars that are posted currently throughout the end of July. Check them out and register at devexpress.com/webinars. Coming up the rest of this week, tomorrow at 10 a.m. Pacific Standard Time, the 5th installment of our Windows Phone 7 series with Chris G. Williams, building a pathfinding system using waypoints with XNA on Windows Phone 7. This webinar builds on the previous webinar from last week to provide a degree of artificial intelligence for the creatures in your game by creating a system of waypoints they can use to navigate the terrain on your map. And if you haven't seen any of these Chris G. Williams webinars, they are all available on tv.devexpress.com, and they're really, really cool webinars.
By the way, I'm
finally,
a fan of,
yes.
I'm a fan. I was just going to say, Amanda, I'm a fan of these webinars. I really like the way Chris presents, and it's kind of a fun topic. So so very cool. I recommend this if that was a topic you were interested in. Sorry, Amanda, go ahead.
No, thanks, Mark. And then finally, Friday, July 8th, this Friday, Towards Code Correctness, Integrating Software Contracts and Unit Testing with Dino Esposito of iDesign. This webinar shows you why you should look seriously at software contracts or code contracts in .NET jargon and what's the appropriate angle and perspective for that. So those are the two final webinars for this week. And again, if you missed anything from this webinar or you want to review any of our previous webinars, check us out at tv.devexpress.com. Again, thanks to Mark and Rory. Thank you all for joining us, and thanks for choosing DevExpress.